Good morning, everybody. It's a privilege for me to be here today. Thank you. I'm part of a group in Anglo American called Technology Development. Our role is to look at what the future mines should look like. So we've got a vision around what we think our mines should look like in 2030. And I'm privileged to be part of a group that gets to look at some of the future technologies, to understand where science is heading, and to be able to try and design what we think some of these mines should look like. For those of you who don't know Anglo American, Anglo American is one of the world's largest mining companies. Our portfolio of mining businesses spans bulk commodities, things like iron ore, manganese, metallurgical coal, thermal coal, base metals and minerals including copper, nickel, niobium and phosphates, and precious metals and minerals, in which we are the global leader in both platinum and diamonds. I think those of you familiar with De Beers, that's part of Anglo American. The company's mining operations, projects and exploration activities, we span Southern Africa, Australia, North America, Asia and Europe. I think just by judging the audience, I think a lot of you have some very light touches to the mining industry. So I think just for the benefit of some of the others who are not fully aware of exactly what we do in terms of mining, I'll just talk to some of the bulk commodities and then perhaps just touch on some of the different mining methods and processing methods that we have. So I think the majority of people here in this room, I think not only live in Houston but are involved in the petrochemical industry. So in terms of some of our mines, if we look at our coal mining operations, those predominantly come from either open pit or not open pit strip mines in the open environment, or underground mines where we have things like long walls or continuous miners. If we look at our copper businesses, those are typically all open pit mines and based in predominantly in Chile. And then if we look at iron ore, is also typically large open pits. And when we start looking at things like platinum, there we've got what's known as a narrow tabular reef. And to give you an example, if you had to take a ream of paper and put one single colored sheet in the middle of that and twist it slightly, that's what we're trying to get out. So we're trying to get out a reef that's anywhere from 700 millimeters up to about 1.2 meters. So that's 4 foot, 1 foot, 2 foot, up to like 4 foot. The typical stoping heights that we're working at are the heights underneath the table. So if you can just picture working all day under there, that's the type of work that we do. So we've got a variety of different mining methods. In terms of processing, the bulk commodities, we need very little processing. They typically just need to be sorted and graded. If we start looking at something like platinum, there's a lot more processing that's required. We need to go through the whole process of crushing, of grinding, getting it down to a powder. When we're down at those levels, then we can start going through processes like flotation, concentration. Ultimately, we can then move into smelting and refining, and it's a very long and laborious process. But those plants are typically analogous to the types of plants I'm guessing that most of you are used to, and that side of our business typically does fairly well in the sense that from a technology perspective, we're not quite, I think, at the level as what a lot of you are, but we typically strive to have really high availabilities and to do the things that we need to do well. Okay. Right, when we talk about mining, we need to be clear that we're talking about one of the most important industrial activities on the face of the planet. Everything you can touch in this room is either grown or mined. Okay? Just look around you. Mining is part of everything we touch and do. So let me simply allow the numbers to do the talking. Gross revenues from the sale of products in mining and quarrying were around 11.5% of global GDP. These are 2010 figures that I'm quoting for you. The value of services consumed to generate this GDP is estimated to be another 10% of GDP. bringing the combination of the two to about 21.5%. If we then consider the contribution of other products to mining, for instance, agriculture in the forms of fertilizer, manufacturing in the forms of steel, energy and utilities in the form of energy feedstocks, transportation, storage, and communications facilitated by products of mining. And if we consider some of the other items, those typically bring together around about an extra 23%. If we bring that lot together, one can argue that mining drives more than 45% of the world's economic activity. Okay. And while we can debate the contributions, the envelope of contributions still exceeds any comparable industry activity by a quantum leap. Okay. At the same time, we can also point to the fact that our industry is one of the least environmentally invasive industrial activities. We take up less than 1% of the Earth's surface. In the extraction of the materials that support our global way of life, we produce less than 3% of the world's carbon gases, and we consume less than 1% of the Earth's water resources to produce our products. We produce materials that are essential to clean polluted air and water and land so that we can support the health and well-being of those that we share our planet with. In simple terms, we make the world as we know it possible, and we make the creation of a sustainable future for our children a possibility. The mining industry has three main challenges. If we look at the first, whilst we have an abundance of resources across commodities, we are not able to develop these resources into reserves due to access and more specific social and legislative limitations. And for those limited new resources that are being developed, they are generally declining in scope and quality. So what that means is that the grades were not the grades that we used to get before, and typically we don't get the homogeneity of those resources that we used to have. Second, because we have selectively developed our mines with short-term economic performance in mind, we have preferentially depleted lower-cost resources, leaving the world to bear the brunt of increasing commodity prices driven by the compounding cost increases of extracting these lower-quality resources. And that's the issue in an industry where you have a 100-year life of mine, but you have to report in quarters. You're always going to go for the good things in order to show the value that you can immediately. The third point is that as an industry, we're woefully underspending on innovation. On a revenue-to-revenue basis, the mining industry spends 80% less on technology and innovation compared to petroleum. Okay? This is an astounding figure when one considers our operating costs are increasing at a rate that is 3 times the consumer inflation rate. Okay? Now, in the context of being the world's most important industrial activity, it would seem to me that we have a problem. Okay? All of this is reflected in the multi-factor productivity index for mining. And this chart happens to reflect the multi-factor productivity index for Canada, but this is exactly the same. If you look at this for Australia, for any other country out there, and what it shows you there is that on a per unit basis, okay, it now takes 40% more inputs to generate a single unit of mineral output than it did 10 years ago. I see that in that graph, they've lumped mining and oil and gas extraction together. I think if you had to separate them, I think oil and gas has probably turned the curve and is probably starting to point up again, whilst I think oil and gas may be propping mining up there, and mining actually may be a lot lower than what it appears on that chart. Okay, and the reason why this is happening is that grades are declining, ores are getting deeper, so that means that we have to go a lot deeper in order to get the same amount of ore that we got before. There are much higher stripping ratios than what we had before, so that means the amount of waste that we need to remove is, before getting to the ore is larger than what it was before. The cost and energy per unit mine is increasing. Skilled labor is stretched and must do more. And the demand for there's a huge demand for improved and sustained productivity, and we need to look at more efficient ways of using our assets. Okay, so having painted such a dire picture, all is not lost. We have come to the realization that we cannot remain on the current path and that a step change of innovation is necessary in order to change our industry. So if we look at some of the broad mining trends that are happening out there at the moment, we're moving from treating ore bodies as big, large, homogeneous blocks to increasing the resolution of the geometallurgical properties and treating each sub-element accordingly. We're trying to remove workers from operating in direct contact with the mining process to safe distances away, and that's been facilitated by automation. So the automation that we're talking there is more around fleet automation. So if you had to picture all of your plants and now give all of those components wheels and let them drive around, that's the kind of problem that we're faced with. The environment is consistently changing, and we therefore need to be able to understand our environment as we move along. We're looking to change current batch processes like drill, blast, load, haul cycles, and replace those with continuous cutting and input crushing and conveying solutions. So we fundamentally need to change the process by which we mine in order to start changing that curve that you saw earlier. We need to start eliminating the energy hogs. So we typically like to move away from pneumatics and hydraulics, move away from diesel, and start looking at more efficient energy means like electrical energy. And we need to improve our planning with advanced modeling and whole-of-process simulation, allowing real-time optimization processes. And we generally refer to this as resource-to-market optimization. And I'm sure many other industries have similar views. We're looking at the increase in the use of intelligent machines. And not just intelligent machines, but intelligent environments. So understand that in our mining businesses, we progress from 2 to 10 meters a day in hard rock. And if we're looking at coal mining, we can move anywhere from up into the hundreds of meters per day. So our environments are continually changing, and we therefore need to be able to measure exactly what happens in each of those environments. And so we're looking at embedded intelligent sensors and processes that communicate state, health, and function, for instance, all in real time. The other good thing for us is that information or operational technologies have matured. The Internet of Things is slowly becoming a reality. We heard some of the discussion around that today. That for us is really interested in that we can have these dispersed independent sensors that can come on and offline on demand and can give us a lot of information that we're looking for. Geospatial data management has come of age. I see some of our partners are here as well today around that area that are helping us resolve that problem. So we've typically been living in a 3D world, but we keep on reducing it to 2 dimensions, and now we're starting to open that up to be able to work in it fully in 3 dimensions. Mass data management methods are delivering value, and that's great because if we just look at the amount of information that's coming in, we need to be able to process it better. And then networks are robust and more mission critical than ever before. I know they have been in your plants for a while, but when you're considering that you're looking at a wireless network under these tables, so if you had to consider how you would put one in this room under all of these tables that would work efficiently and that you're continually moving forward 2 to 10 meters every day and you have to add all the new equipment as you go, that's typically the type of challenge that we're looking at there. All right, and then another important thing for us is that having been technology laggards, other industries have led the way. So thanks to a lot of you in this room, businesses like oil and gas, manufacturing and process, military and agriculture have actually done a lot of work in this area. And so for us to get onto the path and get onto the bandwagon now and to start making some changes, we can learn a lot from you. All right, getting a little bit more specific. Our aims in the future are really is to discover, develop, and manage automated operations in present and future frontiers. So present frontiers are typically the places where we mine today. Future frontiers are we have challenges. How do you mine underneath a glacier, for instance? Can we do ocean floor mining, etc.? Those are some of the future frontiers. And if we look at some of the things that we're doing there, automation and fleet automation in particular is something that's there. So we're trialing some autonomous trucks. We have a few autonomous drills running. And these are totally hands-off, no operators whatsoever. So when we say no operators on board, we still have somebody in the control room having a supervisory capability. And we're looking to extend this into other areas of our fleet. Okay, our environments are predictable and controlled. So it makes it well suited to these autonomous type things. So if you had to take the current autonomous cars that are driving around on public roads, that's probably a less predictive environment than what we have, and we're able to control our environment. So this kind of fleet automation is really well suited to the type of work that we're doing. In underground mining, we're looking at continuous hard rock cutting instead of the batch processes of drill and blast operations. And this will facilitate the time that it takes to reach ore, as well as to be able to develop the working panels that we need to gain access to the ore. Other technologies like blind shaft sinking are things that we're looking into and involved in. And then also new underground mining methods together with automation technologies demand unique positioning, sensing, and communication technologies. There's no GPS underground. So we have to be able to position ourselves underground. We have to be able to create maps for underground. And if you look at that image on the right at the bottom, that is an autonomous robot developed in conjunction with Carnegie Mellon University. That robot is able to map mines and to be able to, it's a technology demonstrator for us in terms of automation. So we have gotten to the point now where we're able to have fully autonomous vehicles underground. We have the technology that's ready for that. And that map that you see there is a map that was created in 10 minutes that has millions more data points than we could ever have if we had to get some surveyors in there to do that type of work. It can be done autonomously. There needs to be nobody present. And we can get accuracies that are good enough for us to be able to automate, allow other machines to operate in the mines, as well as to be able to get operational data that we need from them. Okay, when it comes to processing, we're looking at alternate crushing methods. It uses a lot of energy. Dry processing, we heard some of the comments around that earlier today. And obviously ore upgrading. But where we are is that a lot of the sensors don't exist today in order for us to be able to do these online measurements as we need them. And so we're spending a lot of effort in order to be able to get those sensors up and running. Okay, in terms of our operational technologies, we're pushing hard around advanced planning, modeling, simulation. So in order to bring all of this information around the environment, as well as what's happening with our machines. As our machines, we're not able to access them because they're operating autonomously in different parts of the mine. We need to be able to understand their condition, and we don't want to be transferring masses of data back in order to be able to determine their conditions in real time. We would prefer that processing to be embedded on the machines themselves so that we can simply interrogate the machines and see how they're doing. So we have a few initiatives in that area, and in fact some of our partners are here today around that. All right, so what's happening today is that we've got a number of, there are a lot of people working on all of these solutions for us, many people. But what we're finding is that our issue is how do we get these solutions to work together? We find that we're typically where I think process automation may have been in the 80s, where you would find somebody trying to give you a complete solution right the way from sensors through to a final MES, and we're typically in that boat today. And what we're trying to do is to say to people that you don't necessarily have to do all the parts of it. You can do the pieces that suit you, but that there needs to be some form of interoperability between those solutions that are out there. So we'd like to take a leaf out of the book of what's happened in the history in terms of process automation and get this out there in terms of fleet automation. The parallels are evident, but the marketing of the companies tends to give them competitive advantage if they're able to close everything in together in one place. So the reality of what we have out there is that we have multi-OEM fleets of equipment. These come from one or the other of the large vendors that's out there. The solutions that are being provided to us are typically restricted to a single OEM. We also have a lot of assets that have long asset lives. So if you have to take the life of a shovel or a drag line, something like that, it's around about 30 years. And so you've got to consider that there will be multiple automation upgrades as one would go through, and we suffer a big risk of obsolescence if we don't get our understanding right on how to automate these solutions and how to make sure that whatever we do, and in terms of the maturity of the site and together with the maturity of where we are in the life cycle of the machines as well as the solutions that we put together, that if we're not able to make these solutions work together, we suffer the risk of making our equipment obsolete. And so we're pushing hard for forwards compatibilities, backwards compatibilities, multi-system interoperability in the terms that we need to be able to automate right the way from planning, right the way through to execution, measurement, and back. And at the same time, having multi-OEM interoperability where we can interchange machine parts or different machines and still come up with a solution that's workable. All right, so an ideal outcome for us is a progressive competitive ecosystem where players compete, adding value to the mining process and not by developing closed insular proprietary components. So whilst we have a lot of open systems out there, what we're finding is that a lot of our OEMs are adding small elements into those components and making them proprietary. So an example for that is something as simple as networking, where when a vendor comes to sell you a solution, he'll bring you a solution, but you need to put in his network. So obviously things like that are not acceptable to us, but this is where the market is pushing at the moment. And so we're trying to make sure that we drive and that we get our vendors and our OEMs to appreciate that the value for us isn't about how do we get value into the system and not about how you can sell me a closed package. The value comes in as what I can do for my mine and not what I can do around your individual hardware. And so in terms of our interoperability requirements, we typically don't want to look inside the detail of the black boxes around the solutions that are provided to us. We're more interested in making sure that the boxes fit together. So we're quite interested to make sure that we have that this fits properly in terms of a mining systems reference architecture, where systems are able to be decomposed into our essential elements. And we must be able to manage the interfaces, whether they be software, electronic communications, or physical. And this must all be done in a risk-managed environment. We've heard the discussions today around security. That's only one portion of us. Operational risk for us is obviously something just as important. And so we need to build this up from a risk-managed environment. What's of great importance to us as well is around the skills. What are the skill sets that are necessary in order to implement, to be able to support, to be able to design, and where do we find those skills? How do we develop those skills? And how do we make sure that we have a sustainable workforce going forward? So what I'd like to do is to give you an example of what I've been talking about. It's been mandated for some time that our mobile fleets have collision avoidance solutions on them. These are either collision awareness systems, they're not really collision avoidance solutions. But what you'd find is that, understand we have a multi-OEM fleets and that we would need to put these solutions on. And what we found is that in fact the safety records have not been dropping, even though these solutions have been fitted, and the issue has been one in terms of interoperability. And so what we did was we developed a risk-based solution whereby from our individual sites we can understand what the risks are that we're trying to mitigate. From those individual mitigation strategies, we can link those directly to a unique set of requirements for the collision avoidance systems. And from that unique set of requirements, we are then able to measure quite carefully and predictably what the vendor solutions are able to do, as well as to have our own well-defined need. But we've taken this even further to the point now of being able to specify physical interfaces, data interfaces. And this is quite simply because when you buy some of these pieces of equipment, they already have a lot of the sensors that are required for the collision avoidance system. So in order to prevent the duplication, of human-machine interfaces, etc., we've had to be able to specify these in a way that makes sense. I think our OEMs have found this really useful. We've obviously found it extremely useful. And this is a type of an example of what we intend on doing more with the industry. Where things already exist for our plants and for those types of things, we have no plans to follow any of this. But quite simply, where it doesn't exist, we need to do something specifically for mining. All right, so where do we go from here? I think it's important to say that we partner with academia, we partner with OEMs, we partner with our OTMs. We are members of open collaboration consortiums. We work very closely with our vendors. We have a lot of preferential supply agreements and technology development agreements with a lot of the companies in this room. But what we're finding is that there is a lack of direction from the mining organizations themselves. And so it's in our interest to get together and to start creating some of these, not so much as standards, but in terms of guidelines of how we simply put technology together and how we can really start getting some value out of this technology. So our aim is that we don't want to reinvent the wheel. We want to learn from industries. We believe that mining is now going to be on a rise in terms of a technological change. We need to prioritize our needs. We need to start putting standards in place, or standards, it's a tough word to use, but guidelines in terms of exactly what it is that we're after. And to start getting the ball rolling. We have to change. We have no choice. The industry cannot carry on the way that it is, and so we need to do something. So to summarize, we're at the beginning of a journey. We're learning from other industries. We only need to develop what specifically needs to be done for our industry and to adopt a lot of the other standards that currently exist. And we're looking for people who want to walk this path with us. Thank you.